So I'm going to be looking at the length of a line, or the distance between two coordinates, and I'm going to be using this formula. So the question would say find the distance between two coordinates, or find the length of the line. And I would start by labeling the coordinate x1, y1. Please don't put x1, y2, which I've seen before. It's x1, y1. It's the first coordinate, x2, y2. And I put the square root, and you find the distance in x first. So you find the difference between the two coordinates. So that's the horizontal distance, and then you find the distance in y. It's basically Pythagoras theorem. You've got the line, and you find distance in x, distance in y. You square it and square root it, and you're finding the hypotenuse, so you're always adding. So minus 5 minus 2. So remember, if there's a lot of negative numbers, you are subtracting because you're finding the difference. Okay, so that's the minus, and then the numbers themselves are also negative squared, plus negative 7 minus negative 3 squared. So square root, brackets, minus 5 minus 2 squared, plus, make sure you put the power outside the bracket. Okay. And that gives us a nice neat number. A lot of the times it will give you a surd, and often you would need to keep your answer as a surd. So that's just using that formula. And you can look at the practice if you want. Okay, here is a question. The straight line L1 with equation 4x minus y equals 0, and the straight line L2 with equations 2x plus 3y minus 21 equals 0 intersect at point A. Work out the coordinates of A. So if I have two lines and they intersect, this is simultaneous equations. So two lines that intersect, this is simultaneous equations. So I would start with rearranging that first one, putting it in terms of y. So 4x equals y. Now that I have the value of y, I can substitute 3y. So 3y becomes the following. So I've got 2x plus 3y, but y is 4x minus 21 equals 0. So that is 2x plus 12x minus 21 equals 0. 14x, 2x plus 12x equals 21. I add 21. And then x is 21 over 14. If I divide both by 7, just put it in your calculator if it's easier, we've got 3 over 2, 1.5. So that's x is 1.5, y is 4 times 1.5, 12 over 2, which is 6. So the coordinate of A is 1.5 and 6. And let me make a lot more space here for part B. There we go. So that's part A. And then it says work out the area of triangle AOB, where B is the point where L2 meets the x-axis. So for B, you must sketch the diagram and label the points of intersection. And by that I say points because the intersection where the two lines meet, but also where the lines meet the x and the y axis. Okay, so for B, I need a coordinate. So something like this. There we go. So I need a y and an x-axis. I also need to figure out where these lines meet. So 4x equals y. When y is 0, x is 0. So this line goes through 0, 0. Okay, and the other line, 2x plus 3y. 2x plus 3y equals 21. When y is 0, 2x equals 21, so x is 21 over 2. So you've got 10.5, 0 is one of them. And when x equals 0, 2x is gone, 3y equals 21, y equals 7, so you've got 0, 7. And this line is a positive line, positive gradient, it's going that way. And this line, if I rearrange it, 3y equals 21 minus 2x. So this is a negative line with a negative gradient, so it's going like this. So let's have my ruler. This line goes through so that's y equals 4x, and the other one is going to go through 0, 7, okay, so there we are. So that's the line 3y equals 21 minus 2x. This is the point A, and we've established that A is 1.56, so this is 7. This is 10.5. This here is 1.5, and there is 6. And I want the triangle where B is the point where the line meets. Well, L2 meets the x-axis. O is the origin. So this is O, and this is B. So I want this triangle. There. Well, I hope you can see that this distance from O to B is from 0 to 10.5. So the base of the triangle, the base is 10.5. The height of the triangle, so that's the, that's the base. And then that is the height of the triangle. And the height is 6. So the area is half times base times height. Which is 31.5, and it's units squared. We don't know what the units are. The units squared, 31.5. And this is a question from the textbook, and it's an exam question, so I thought we'll go through it as the final example. The points R is 5 minus 2, and the point S is 9, 0. So this is 9 minus 2, and this is 5. And they lie on the straight line L1 as shown. Work out an equation for the straight line L1. So L1 goes through two coordinates, 5 minus 2 and 9, 0. So I have x1, y1, x2, y2. And the first thing I need to do is find the gradient. So that is y2 minus y1, so minus negative 2, and then 9 minus 5. So this is 2 over 4, so the gradient is a half. And then I'm going to use my formula for finding the straight line. So that's y minus y1 equals mx minus x1. So I will use this one. That will make life easier. So y minus 9 equals a half x minus 0, which is just x. And if I multiply everything by 2, I get 2y minus 18 equals 1x rather than a half x. And it didn't give me a specific way of giving the equation, so I'm going to leave it like that. So let's go all the way down here, make a lot of room. Okay. So that's part A. And then the straight line L2 is perpendicular to L1 and passes through the point R. Work out the equation of the straight line L2. Okay, so perpendicular. So the first gradient is a half, therefore the gradient of the perpendicular is negative 2. And we pass by R, which is 5, negative 2. So I have x1, y1. Y minus y1, which is negative 2, equals negative 2x minus 5. So that's y plus 2 equals negative 2x and a positive 10. So y equals negative 2x, and I'm going to take away the 2, so plus 8. So that's L2, and that's L1. And then it says work out the length of RS and TR. So I can do RS straight away because I've got the coordinates, but I will need to work out T, and T is where L2 meets the y-axis, so it's the y-intercept. Is it very easy? Yes, it is. T is the point 0, 8. Okay, so RS, let's start with RS, and R was 5 minus 2 and S was 9, 0. Yeah, so x1, y1, x2, y2. So I've got my square root. 9 minus 5 squared plus 0 minus negative 2 squared. 9 minus 5 squared plus, okay, so that is 2 root 5. And then I want to find TR. Okay, so TR. R is again 5, negative 2, and we said T was 0, 8. X1, Y1, X2, Y2. TR. X2 minus X1 squared plus 8 minus negative 2 squared. 0 minus 5 squared plus 8 minus 2 squared, and that's 5 root 5. Okay, 5 root 5. Leaving your answer in the form k root 5, which we have. Work out the area of triangle RST. Okay, RST. So we need to add a line there, RST. Okay, so I would find what this point is, because that distance on the x-axis can be used as the height of the triangle, and the base is TR, which we have found. So that point is the point where L2 cuts the x-axis. So I've got L2 is here, and it cuts the x-axis when y is 0. So 0 equals negative 2x plus 8. So minus 8 equals negative 2x. So x equals a positive 4. So that distance from 4 to 9 is 5. So the height of the triangle, height, so let's put that's the x-intercept, and the height is going to be 9 take away 4, which is 5, and the base is TR. Okay, so the area is half times 5 root 5 times 5. So I get my calculator, and I've got a half times 5 root 5 times 5. 25 over 2 root 5. Okay, and that is the end of the video.